Hello, everyone. Thank you all for joining. Welcome to the InRhythm Quarterly Summit. And for those who don't know me, I'm Parag Katkar. I'm the head of consulting practices at InRhythm. As a part of our InRhythm Quarterly Summit, we are hosting a series of several hands-on interactive coding workshops on the latest technology trends. And today we are hosting the fourth workshop of this series, which is our DevOps workshop. A little bit more about what the quarterly summit is. Learning and growth is a core value for us, and our thought leaders across our practices, they continuously identify the latest trends in the industry for their practice areas, and they plan weekly lightning talks on those trends. And at the end of every quarter, we host a quarterly summit event where we go over, summarize the technology trends that we covered over the quarter or any new trends at that time. And we do hands-on coding workshops to learn these skills where our consultant discuss their learnings, and then they share their knowledge on applying these skills on actual projects, and how you can learn from these trends and the best practices around that. So I'm super excited about today's workshop. And without further ado, I'm going to hand it over to James Putman to go over the agenda for today's workshop and take it on from there.
Awesome. Thank you very much, Parag. All right. Welcome, everybody. And like Parag said, we're going to start off going over our itinerary for today. So Propel workshop for DevOps. We're going to start off kind of covering a little bit about a couple tools that we find interesting from the DevOps perspective. So we're going to demonstrate tools for provisioning infrastructure, as well as how to construct self-servicing platform for provisioning resources. We'll do that with an application called Backstage that was developed by Spotify. We'll also cover some infrastructure cost tools called InfraCost. We'll be using that with Terraform. And we'll also cover Pulumi, which is another infrastructure as code tool, and we'll be using Python to work with that. Why IAC? It makes things a lot easier. The old days, having to provision resources manually, very tedious, very time consuming. So infrastructure as a code makes this a lot faster. Backstage, we're going to be using this. Kind of helps with creating a developer portal for your internal teams, and Toph will be able to go over that more in detail later on. So we'll start off with a nice introduction. We'll follow that up with Pulumi and Python. We'll have a hands-on workshop with Pulumi and Python. Then Toph will come in and start talking about InfraCost. He'll also cover working with Terraform. We're going to have a quick break from 2:50 to 3:10. Then we'll meet back with another lightning talk about Backstage, have a hands-on lab with Backstage, have one more break, and then we will close things up at around 4:30 with some Q&A and anything else that we need to cover. So with that being said, let's kick things off. So welcome again to the Spring Summer 2023 DevOps Workshop. Speakers for today, my name is James Putman. I'm a senior DevOps engineer at InRhythm, and good buddy Toph is a solutions architect here at InRhythm as well, and we'll be leading today's talk. All right, so we'll first off talk about automating cloud infrastructure with Pulumi and Python. So what is Pulumi? How does it work? Why should you use it? We're gonna have some links, and then we'll open it up for a couple questions. So first off, what is Pulumi? So Pulumi, if you're familiar with infrastructure as code, it is a tool that allows you to provision cloud resources much in similar way that Terraform does. So if you're familiar with Terraform, Pulumi is a very similar tool, but it does differ in a couple different ways. One of those ways is that it uses a general purpose language. So Terraform uses HashiCorp language, which, if you're familiar with it, that's cool. But if you're somebody moving into using Terraform or using these new using these tools, you might not be as keen to learn a new language. So one of the benefits of Pulumi is you can come in knowing JavaScript, knowing Python, knowing Go, and you can define your pipelines using those languages. Another cool thing about Pulumi is it integrates easily with cloud providers. So AWS, Google, Azure, the list goes on. So it makes it easily integratable, and it is also open source. So you can also contribute to it. The user base is growing. It's not as popular as Terraform right now, but it's getting there. So now we kind of covered what is Pulumi, and let's talk about how it works. So you can think of the project. We're going to kind of use some analogies here. So you can think of the project as kind of like your GitHub account. And then your program would kind of be like, your code or your repo in that account. And then you have your stacks, which would kind of be similar to your branches or your environments. So these kind of contain different states or deployment states for your project. So the program is what uses the language specific or the general specific language. So whenever you're defining your Pulumi program or your project, the program is what's going to be using that specific language. So for our example today, our program is going to be using Python. And then over here on the right-hand side, we had some couple of commands there that we can use to provision our resources, but you might have accidentally went away there. Okay, there we go. So yeah, Pulumi up, these are just a couple very common commands that we can use. Pulumi up will deploy the code or the resource changes. Pulumi stack, you can manage the instances of your project using the Pulumi stack command. Config, Pulumi config, you can alter the configuration. And then Pulumi destroy, this will destroy all of the resources that were created by the Pulumi up command. And this is very useful. You definitely want to make sure you destroy your resources after you have them created if you're practicing, so you don't want to let those resources run in the cloud. Continuation on how it works. We're going to dive a little bit deeper under the hood here. So it's broken down into three main parts: language host, the CLI and engine, and the providers. So the language host, like we were just talking in the previous slide, is part of the program. And it defines the resources in that familiar language we we're talking about. So Python would be our example here. The language executor launches the language runtime. So whatever language you have, it's going to launch the runtime. And the language runtime communicates with the deployment engine. And the deployment engine detects any kind of resource registration. So whenever you add a new resource, it's going to be registered. The deployment engine, they communicate back and forth and kind of determine what resources are going to be deployed. The Python runtime is contained in the Pulumi package, which we'll be installing later. All right. And so the language host communicates with the deployment engine, and then from the deployment engine, it's going to compare this to the current state. So it's going to say, okay, language is telling me we want to add these resources. What's our current state look like? So it's going to communicate with the state and determine whether or not these resources need to be created, whether or not they need to be updated or not, or deleted. So once it gets confirmation, it's going to communicate with the provider. And the provider you would think of, as AWS, Azure, Kubernetes, and they will implement the desired state. Now, these resource plugins are binaries that are used to communicate with various providers. And depending on where your state is stored, these resource plugins are going to be stored within that Pulumi state location. And then SDK provides the resource bindings for the resources. And so in a nutshell, this is kind of what's going on behind the scenes. And so we can touch a little bit more on this later on when we get to our workshop. Now, why should you use it? So we've covered a couple different aspects of Pulumi. For those folks that are familiar with Terraform, like I was mentioning earlier, there are some pros and cons. I think one of the biggest pros for me is being able to use, a specific language that you're comfortable with. It also allows for more flexibility. But there are also some minute differences that could make it a lot easier as well. So Terraform doesn't have a lot of conditional options. So when you're trying to add some logic to your Terraform scripts or your files, you might have to go add a couple extra steps to get the desired logic that you'd like. Similarly, robust utility functions and types. So getting a string value or different utility functions exist within the Pulumi sphere that are kind of lacking within the Terraform. Easier for developers to work with. This is based on the fact that developers can come in with a programming language that they're comfortable with. So if you have a small dev team and you have the need for provisioning resources and you don't want to hire somebody that needs specific understanding of HashiCorp language or anything, if you have a developer shop that works with Python, you can easily transition into using Pulumi because you don't have to really learn any new language. It can also integrate with Terraform providers in addition to the many providers that it also already integrates with. And one of the benefits is it supports a lot of automated testing as well. Unit, property, integration testing, and supports testing frameworks. So those are all some cool pros, but unfortunately, it's not a perfect world. So documentation is still lacking because it is still a fairly new product. The community is growing, but just because of the amount of time, it doesn't have a whole lot of documentation compared to Terraform. So it's still growing. There is a Slack channel, a really cool community that helps answer a lot of questions. So that's where I've gone to get some of my questions answered, and of course Google. And community is small. There are some benefits that are also kind of locked behind a paywall. So you can manage your state. You can store your state locally. You can store it in an S3 bucket. But if you want to utilize, the Pulumi service state management, you have to pay for their services. So it's a little bit of a trade-off. And cloud details, not as good as Terraform. So again, it just comes with the maturity of Terraform that some of these aspects of Pulumi are still lacking. And finally, we got some useful links here. So these are mainly pointing us back to the Pulumi website. I mean, even though the documentation is still growing, documentation is really good, I feel. They provide a lot of good resources, how-to documentation, just example projects that you can build, get going. So Pulumi website, the Pulumi blog for any kind of new news information coming out. The Pulumi community page has some really good information, some best practices, and also mentioned that there is a Slack channel for Pulumi. So if you are on Slack, definitely recommend joining up and talking with folks there. All right. Well, other than that, I will open up for any questions.
So how long has Pulumi been out?
I'm gonna Google that real quick because I'm not exactly sure.
Okay, so maybe a better question: have you been able to use it yet on any product?
2018 is when it came out.
Okay.
So personally, I haven't had a chance to use it on anything at work yet. I mean, I would love to give it a shot. Just working with getting this presentation ready and just kind of messing around with it. I kind of stumbled upon it whenever I was preparing for my last lightning talk over Terraform, and I saw that it was a lot of people were talking about pros and cons between Terraform and Pulumi. So that's kind of how I got turned on to it. And just the more that I have kind of dove into it, I've been learning Python on the side and everything, getting better at that. And when I found out that, you know, it was language agnostic, you could use Python to kind of define your infrastructure, that's kind of really kind of piqued my interest. And so, yeah, just kind of learn more about it, have more fun with it. But unfortunately, haven't had real world scenario where I've been able to implement it yet. Yeah. Who knows? Maybe after this workshop, we'll get some requests.
Yeah, Ted, for your like regarding after Pulumi was released around 2018, there was definitely a lot of discussion around it, you know, since it brings infrastructure straight into the hands of the developers. You'll see in the workshop that the code is, you know, it's native Python code, JavaScript code, things that application developers are familiar with. But the hype around it, it was a bit short-lived. I mean, people are definitely still using Pulumi out there, but Terraform did have an answer for that, and they came back with Terraform's CDK, which also leverages, you know, Python, TypeScript, Go, and other programming languages to wrap around infrastructure as code.
Yeah, so there's
Cool,
definitely
great guys.
Yeah, definitely Terraform and Pulumi. Pulumi does something, Terraform's like, oh yeah, we can do that too, you know? So it's definitely, there's some Pepsi Coke going on there, but yeah, I think it boils down to really, you know, what does your company need? You know, are you a small company, a big company? What kind of resources do you have? But yeah, very good
Cool.
question.
Yeah, great.
All right. Any more questions? If not, we'll go ahead and move on to our next step. All right. Well, thank you again for the questions there. We'll work on or move on to our DevOps workshop. So before we get started, for the folks that are participating in this workshop today, you should have received an email with some installation instructions on what you need installed prior to the workshop. But if you haven't, we can also help get things going for you. Before we get started, our prerequisites for this workshop exercise, we're going to be using Pulumi. We're using the command line interface. For Pulumi, we're going to need Python installed, and we're going to need our AWS credentials. So what we're going to start off doing is we're going to begin by defining our Pulumi YAML file. We're going to add our main Python file and define our resources within that file. And then we're going to deploy it to AWS. So we're going to define our Pulumi YAML file, create our main Python file, and then deploy our resources to AWS. So let me switch on over here.
And for those following along, it doesn't necessarily have to be Python. I'm going to give it a try in JavaScript. There's also TypeScript and Go as well. I don't think Java is supported yet.
Yes, and we will all right. So if you all have want to clone the repo for, if you want to follow along, you can clone the repo from our InRhythm workshop, Pulumi with Python. We have this set up in a way to where if you want to go ahead and pull the cake out of the oven like they have at the end of those cooking shows and have that product already ready, you can work off the main branch. We also have it broke up into different branches. So we're going to start off working on the step 1 setup branch. Going to move on to step 2, set up the S3, and then step 3, static hosting for our branches. So if at any point in time you do start lagging behind or something happens and you need to catch up, you can always check out one of these branches to get caught back up, and it will have everything that you need to proceed through the rest of this workshop. So I'm going to check out our step 1 setup, start building things out, and we'll end up with our main product, which is the main branch. All right. So the first step, we need to define our Pulumi YAML file. And so this Pulumi YAML file is going to kind of define our project. So in that last, one of those first slides we were looking at, we saw how the project is kind of like that outer resource. So we're going to give it a name. We're going to call it, say, do DevOps workshop. So the runtime that we're going to be using for this is going to be Python. Configuration. There we go. So Python, it's the runtime we're going to be using for our language host. So we want to add that. I'm going to add some options. And now with Python, we're going to want to create a virtual environment. And this virtual environment will allow us to, when we install our packages for Python, this will keep it kind of nice and clean. So everything will be contained in this virtual environment instead of having to install them on your actual machine. So there we go. And then we'll give this a description. All right. So this right here is going to be our Pulumi project YAML. And let me see here. Folder. Right, create the tool project. Okay, we got project name in there, description. Okay. And then with our next part, we're going to add our main Python file. There we go. All right. Now with this here, we need to import a couple things. So we're going to import MIME types, and we're going to import OS. These will be needed later on when we start to define our resources a little bit more, but we'll go ahead and import those for right now. And then from Pulumi, we're going to import file asset, output, and export. And again, these are just packages that we're installing, bringing in that we're going to need for defining some of our resources here. Pulumi AWS. All right, so we've got our imports defined at the top. We're going to start off by creating our first S3 bucket resource. And we can call this one web bucket. And from S3, we want to create a new bucket. And we're going to call this bucket S3 workshop bucket. All right. So starting off, defining our bucket, and then from here, we're just gonna see if we can get this bucket going up in AWS first. Before we go any further, let's just see if we can see if this bucket is appearing. Bucket name. Bucket.id. And so we're not using this right here yet, so we're getting some squigglies. But before we do this, we have our requirements text here. So we're going to install our requirements into our, we need to get our virtual environment going first. So if we do a, so we're going to create a new stack. So with our Pulumi up command, we're going to create a new stack first. We're going to call this stack dev. Okay. So whenever we did our Pulumi up, you can see it created a virtual environment up here. And this virtual environment was created because within our main YAML file, like this is the project that we defined. And from our runtime, we select Python, and we had virtual environment. So our virtual environment has been created from our Pulumi up. So it's taking a little bit of time here. And then right here, it's asking, all right, so we're creating resources, output, and resources. We're adding 2, so we're adding an S3 bucket. It's asking us if we want to perform this update. Say yes. All right. And so we can view this in our browser if we want to, or we can swing on over to our S3 management console. If we do a refresh, you can see right down here, we have our S3 workshop bucket. And we don't have anything in here right now because we haven't really added anything to our bucket within our main Python file. So jump back over here. I'm going to spiff this up a little bit. So for our S3 bucket, we're going to add a little bit more details to this. So add comma there. So our website is S3. Add some arguments. And then index document equals. Right. Fix some of this indentation here. Python loves indentation. All right. So add a little bit more, defining our index document, setting it to our index HTML, and in our repo, you notice there is some documentation that is in here already. This is the website, the static website that we will be hosting on our bucket. So just give you a heads up what that's doing there. So we need to create a content directory. So it's specifying our www folder is going to be our content directory. And then we're going to iterate over all the files in this directory. And for each file, we're going to create a new bucket object for those files so they can be stored within the S3 bucket. So for file in os.list directory, for the content directory, we want to set file path to the operating system path, join the content directory and file, and then the MIME type. So whatever type of file that we're going to be going over, we're going to we're going to infer what those file types are by using the guest type function from Python. So for each file that it's iterating over, Python's going to be able to determine what kind of file it is and create a new object for it. Another bucket object. So for file, then we're going to set some of the variables on this bucket object here. So bucket equals web bucket ID. So we're setting the bucket equal to the ID of the web bucket. Source is going to be file asset. So we're going to do the file path. And then the content type. So content type, again, we're not really sure what the content type is, but we're going to leave that up to Python to determine that. Here's my type. All right. So we've taken care of the files in the www directory. We're going to be assigning those to bucket objects within the S3 bucket we created. But now, in order for this bucket, the static site to be accessible to folks outside, so publicly accessible, we also need to set a public read policy for this bucket. So we're going to define a new function for this. So public read policy for bucket. And it's going to take bucket name. And we want to return output JSON dumps. All right, version. That's 12, 10, 17. Statement. And some of the stuff, pretty sure you can just like copy from the AWS instead of typing all this out. But for demo purposes, we'll principal action. What kind of action do we want? It's 3. We want to get object. Right. And so that's that part. And then we need a resource. Finally, we're going to define the output format. There we go. And bucket name. All right. Cool. So we have just created a function that is going to set our public read policy for our bucket. We got a few more lines and we'll be ready to deploy this. We need to set the bucket name equal to the bucket ID, web bucket ID, and we need to set the bucket policy. So we define the function, but now we need to actually use that function to set the policy. So bucket policy +3. So we're setting the bucket policy, and the bucket policy is going to be called, guessed it, bucket policy.
Hey, James, if you don't mind me asking, how similar is this to actually creating it inside like AWS, like in some of their interfaces? Like if we were creating a custom policy, or if you've done that, you may not have done that.
So, I mean, I have created policy, but I haven't had a whole lot of experience creating policies. So there are a lot of similarities.
Yeah,
But
the JSON that you define there is exactly the same JSON that you will put into the
yes,
policy input on AWS.
yeah,
So
Oh yeah, yeah. So I see that now that this is actually JSON. I had missed the JSON line there for a second. So I see
yeah.
what you're doing. Yeah, I was thinking it looked just like what you would do anyways.
That's
Like,
what I was saying. Like
Yeah.
yeah,
you could straight up copy this and throw it right in there if you wanted to. But like, yeah. So for the most part, I mean, using different languages to kind of define something that's going to be a little different. But yeah, like
yeah,
Tom was saying, the JSON straight up just like AWS.
got you. Okay, great, perfect. Thanks, guys.
No problem. Good question. Thank you. All right. So bucket policy, we need to once again set the values here. So bucket, we're going to call it the bucket name. And then the policy that we're going to add to this is the public read-only policy for bucket. We're going to pass in the bucket name. All right. And then we need to also export the website URL. So website.
Yeah, I just wanted to add a quick note there. The reason he created that bucket policy was to make sure that when the S3 bucket is being statically hosted for the static website, the objects and the paths can be retrieved when you access it via URL. Otherwise, it would give you an access denied.
Yes, thank you very much for that clarification. Exactly. Yeah, so otherwise, yeah, we'd just be creating this, nobody be able to get to anything. So all right. So now that we have finished writing out our main Python file, we got this requirements text. We need to install these before we can actually use our packages up here. So we're going to run a command real quick. It is pip3 install our requirements.txt. And this is going to install the requirements that we have in there in our requirements text file into our virtual environment. Takes a little bit to think about it. We're getting there. We're getting there. All right, we got our squigglies gone. It's liking it. Maybe we'll get there one of these days. Okay, so got a little error here, but I don't think that's going to prevent us from moving on. So now we've got our packages installed from our requirements document. Do our Pulumi up. We're going to select our stack that we had created earlier. So we're previewing the update. And so if you notice now, our output's a little different than earlier. So we've got an update. So we're going to update the original bucket that we created. And then we are also creating additional resources. So that for loop that we created, we're going to create 3 new bucket objects because in our www folder here, we only have 3 files. So each one of those files is going to be a new object stored under the S3 bucket, which is what these resources are. And finally, we have our bucket policy that we created there at the end. Down here, say we have 4 to create, 1 to update, and to confirm, we'll do yes. Yeah, cool. And so we can do a couple things. So we can check out the website URL. So this is the static website. Oops. Maybe paste it straight into the browser. Let's see what we get there. Hey, look at that. Hello, S3, made with heart, with Pulumi and Python. A lot of heart went into that. And then if we go back to our S3 management console and we do a refresh, we can come down here and see we have our S3 workshop bucket. And if we click into it, we also notice that we have those three files that we defined as S3 objects, and they have been added to our bucket. And as a final step, always good practice to destroy your environment when you're done with it, because these resources will continue to exist without proper destruction. So to break down this project, we're just going to do the old Pulumi destroy. And again, it's going to ask us to choose a stack. We're going to choose dev. Perform destroy. Yes. And it also says like, hey, are you sure you want to do this? These are all the resources, outputs, everything. We're going to confirm yes. So it's going to destroy it. Deleted, and resources in the stack have been deleted, but the history and configuration associated with the stack are still maintained. So this is that state. If you want to remove the stack completely, run Pulumi stack remove dev. So we could additionally, go into it a little bit more and destroy it. That's pretty much Pulumi in a nutshell. So I know I'd mentioned about the state files. And where is state stored at? Because that is one thing with working with Terraform. You can have stored state stored locally. And so with Pulumi, stored can be stayed in a lot of different areas. State can be stored in a lot of different areas. If you have the Pulumi service account, so if you are logged into Pulumi, let's see if I can log in here. I think this is, oh, wrong one. Oh, it keeps trying to sign me in under this GitHub one. But so for the state, let me see if I can pull up my Finder here real quick. You can store it in an S3 bucket. You just have to specify it using the Pulumi login. And I can show you where it is stored locally on your machine because you can store it locally. So at your system level, it will create a Pulumi folder, and your stacks is where it will store your state locally. So for instance, if I were to do Pulumi login, so Pulumi login, just regular, will log you into the Pulumi service, which is what we're looking here. And Pulumi service will store your state within Pulumi. That's what I was referring to as far as if you want to access your state from Pulumi service, you have to have the paid account, which sucks. But you can store it locally on your machine. You can store it in an S3 bucket. Within our Pulumi YAML file, you would just create, I think it's a backend variable. And then I think the backend variable, where was that page at? Oh, I had the page open on a different one. Okay, here we go. This is the other one I was looking for. So the stacks that we built earlier, so these are just some past projects that I was working on. But jumping into these stacks is where you would be able to find your state file, but unfortunately I lack the option over here. But this is what the Pulumi service page looks like. You can come in here and check out the resources that you create, and it would take you straight to Amazon from there. So I guess that's pretty much the gist of Pulumi in a nutshell. You know, state files will definitely, you know, track the current configuration of your project and make sure that you don't run into any kind of configuration drift. So definitely want to make sure that wherever you're storing your state file, that is in a secure place, that doesn't would involve any misconfiguration or altering of those files, because maintaining proper state is very important when working with infrastructure as code. And yeah, Pulumi backend is how you would determine where that state file is located. But does anybody have any other questions at this point in time?
Where was the local state stored?
Yeah, so I will give me 1 second. I had the link up here, but I think.
So I gave it a try as well in parallel and with JavaScript. But when I did Pulumi up, I realized I had the wrong AWS credential set. So I force killed it as it was doing Pulumi up. So, you know, I think that usually when you do it in Terraform, it messes up the state file, and, you know, you kind of need to reconfigure it. So like, I think the next course of action would be to delete the state file, but I'm not clear on where I can find that.
Yes, good question. All right, so I figured it out. So if you want, so the Pulumi login command specifies your backend. So if you're using an S3 bucket, you would provide like the link to your S3 bucket. If you're using the Pulumi service as your backend, you just do Pulumi login and it will automatically log you into their backend. Or you can do Pulumi login local. And Pulumi login local, so you see here logged into James mbp.lan as James Putman, file / today. And so if we go to Finder, we see our Pulumi here, and so our stacks is going to be stored under stacks. So I'll give a quick demonstration real quick of how that works. So prior to this, we had our Pulumi backends linked to the Pulumi service. And this Pulumi login local, I just switched the backend to my local desktop. So whenever we run Pulumi up again, it's going to, we can ask for a new stack. We'll call it dev. Call it dev2 this time. Passphrase, I'm not going to use a passphrase. And so because we're creating it locally, we can see our stack was created here. And do you want to perform this update? Yes. And so our resources were created. And if we go down here into Finder, we should see that stacks now has a bunch of new metadata files created. But this dev2 JSON, that one, this is the state file that looks familiar. This is the droid. This is the droid we're looking for. And so, yeah, so depending on what you have your Pulumi backend set to, will depend on where the stacks created, where those state files are going to be stored at. And so within our Pulumi YAML file, thought I had, yeah, I had a note around here. Let me see if it's in this one. Pulumi YAML. Yes. Okay. Yeah. Okay. So it's backend. So here is how you could define that in your YAML file. Whoa. There we go. All right. So yeah, if you're wanting to, so you can set your backend through the Pulumi CLI with the Pulumi login command, or if you want to, you can define it within your YAML file by using backend URL. So with this one, I created a bucket last night just to test it around, and yeah, it was storing state within this bucket. And similarly, you can also define it to have it stored locally on your desktop, depending on what path you want to specify. But the YAML file will override whatever is set within the command line interface. So at a hierarchical level, YAML is the end all be all, but if it's not defined here, it goes off whatever is defined within the Pulumi CLI. So does that help answer your question, Tom?
Yeah. No, that did answer it. I just tried it. I used the local path, and yeah, it asked me to create a new stack. So I did that, and I was able to successfully deploy the static site.
Nice. Very cool, very cool. All right. It's all some good questions, folks. Does anybody else have any questions, comments, concerns? Anybody having any issues need to take a look at? I know, I feel like I've been up here rambling a lot, and I hope I'm not leaving anybody in the dust over there.
I mean, I was trying to get it set up. Not quite there, but I think it's just like I didn't have some of the requirements already in place. So, so like I was just trying to do the Pulumi or Pulumi AWS package, I guess, to try to link it. So,
Oh, so linking your AWS account to Pulumi?
yeah. So
Okay.
it looked like I needed to do, I guess I was following this Python piece, like a pip installer, but then it looked like I maybe don't have pip installed, and so I was just trying to figure that out.
Gotcha.
Yeah,
So,
but I don't want to hold us up. I know I mean, I know we still got about 5 minutes on this segment, but I don't want to hold us up too much on that. So
yes, but no, that does bring up a good point, Ted. So for if anybody is stuck on getting, so if you are having issues with your AWS access keys, you can either, if you have the AWS command line interface installed, you can update your credentials using the AWS config file. Or if you do not have AWS CLI installed, you can also export your keys as environment variables. And this should allow you to access your AWS account from Pulumi. But if anybody does have any issues, yeah, we got 4 minutes, but we can also look into it a little bit later if you do continue having any issues, because I want to make sure you guys are having fun with this.
it's definitely fun for sure. Yeah.
Cool. Well, with 3 minutes left, yeah, does anybody have any questions, comments, concerns? I mean, it's I thought it was pretty neat, being able to use different languages to provision cloud resources. It's future's cool.
Yep, that was really cool. Nice job, guys.
Yeah. Thanks, James.
Hey, not a problem. Thank you all. Well, I will go ahead and stop sharing here. And I'll hand it over to Mr. Dahl.
Yeah, we'll take a quick 10 minutes break, and then we'll get started. All right, I'll get started. Okay, so for the next part of the DevOps workshop, we're going to talk about Terraform, a competitor to Pulumi, definitely has a much larger community. It was originally built by HashiCorp, which is also a pretty big company, and it's also widely prevalent in use, especially when it comes to implementing infrastructure as code. Furthermore, we're going to talk about a tool called InfraCost. We'll see how this tool actually fits into the theme of the current economic climate here in the US at least, and across the world as well, and how we can stay more cognizant of the monetary concerns when it comes to provisioning resources. So Terraform. Oops. Let's begin by taking a look into the world of infrastructure as code as achieved using HashiCorp's popular tool, Terraform. So infrastructure as code. So with infrastructure as code, we do get the same benefits of application development when provisioning infrastructure. And this concept itself kind of follows the whole left shifting paradigm, where we can bring the whole process of provisioning infrastructure, which originally used to happen later on in the life cycle, but now we can bring it earlier as part of application development. And not only that, because this is now implemented as code, we can use everything that we do when it comes to writing code, which includes source code management and version control tools. And furthermore, we can now include, when writing infrastructure as code, we can also participate and collaborate on it with pull requests, the same way we do with application development code as well. Furthermore, we have the ability to maintain multiple cloud providers at once, as we saw in James' presentation, even with Pulumi and at Terraform, for the architecture that you want to stand up for your organization. It isn't strictly AWS that you need to use. You can also import, Azure or GCP and have a more hybrid setup as well when using infrastructure as code. And also the ability to provision a full stack entire infrastructure at once. So with infrastructure as code, you can have your entire infrastructure architecture provisioned at once and destroyed together as well. And ultimately, what this allows you to have is a separation of environments, an entire infrastructure architecture for development, an entire architecture for staging, and the same entire setup for prod as well. And it's kept consistent throughout each environment. And finally, and also we can modularize the pieces of infrastructure. So since it's now maintained as code, I can write my own modules that comprises of multiple different sets of resources, and even submit it to like the Terraform registry. I'm sure Pulumi has one as well, and to keep it more modularized and give it the ability for reuse. And similarly, increases portability and flexibility when we do this. And finally, we have the full automation of infrastructure as well. The full automation of infrastructure, we can use CI/CD pipelines since it's now applicable with source code management tools. We do also get the capabilities of CI/CD with it as well. So here comes Terraform. And as I mentioned earlier, Terraform was originally built by HashiCorp, and it uses HCL, which is HashiCorp's configuration language. And like other configuration languages, it's human and machine friendly. Not only that, it's declarative. So the code is exactly as you see it. So, it's just a matter of defining the resources, specify the settings, and that's exactly what will be provisioned. So no need to worry about, um, logical branching or, jump statements or anything like that. Everything you see is exactly as is. And each of these resources does provide outputs, and those attributes that are outputted can be then used with other resources. So for example, in this code snippet right here, we basically have a typical Elastic Beanstalk setup. And for Elastic Beanstalk, when deploying, a web application, there's two components to Elastic Beanstalk. There's the application and then the environments. So as you can see here, the exported, the output of AWS underscore Elastic underscore Beanstalk underscore application is then used in the second resource, the Elastic Beanstalk environment on the second line. So with this, I can, we can have a contiguous chain of resources that get dependent on one another and get the resource, gets the settings and, all the outputs from one resource used in another. So let's take a look at how Terraform works. There's a few simple stages for provisioning your infrastructure. And the first thing is that here on the left, if your organization, before adopting Terraform, already has resources provisioned, you can actually pull those in by running Terraform import. So that way you can get it maintained onto your state file. Once that's done, you can add more configurations to it. So add more resources that will also get added to the state file once you execute Terraform plan. Terraform plan is pretty much a dry run of showing you all the resources that are to be added, that are to be changed, or to be destroyed if they've been removed from the code. And then finally, the output of that plan, you can apply it. And applying is where the execution takes place, and it's going to render and provision all those resources to your respective provider that was defined, whether it be a cloud provider or local. And just one note that the state file that is used for all of this is typically a JSON file, kind of what we saw in James' demo for Pulumi, and it has a representation of all the resources and its state. So in the event there are multiple engineers looking to provision different resources to the same system architecture, this state file would need to be maintained centrally. And that's where we saw James talking about an S3 backend. So if this state file is maintained centrally on S3, anybody trying to update the infrastructure via code, they can refer to that state file as the source of truth. All right, and that's pretty much, those are pretty much the stages to provisioning Terraform. As we saw, the code is declarative. We don't have the flexibility that James kind of showed. As an application developer, writing JavaScript, writing Python feels more natural than having to learn HashiCorp's configuration language, which is fairly simple, but it is a new language that needs to be learned. So while it doesn't have that flexibility, it is very simple to kind of write the code for your resources, plan it, see what's to be provisioned, and apply it. So now let's look at a popular tool that was released a few years ago called InfraCost. And now this tool is going to give us the insights into the cost breakdown of the plan file that we generate when running Terraform plan. And this is pretty much a game changer because, when we're collaborating on PRs for Terraform, we'll talk about the settings, if there's any adjustments we can make or any other resource we can make for, a sound architecture. But with InfraCost, it's now going to add cost to the discussion. So, it's really going to bring it up front, when working with infrastructure as code with Terraform. So let's look into, why even use this at all, especially in this day and age. So we're all aware of this. Over the past year, the economy has made a significant impact on the tech industry, especially. Stock prices are looking like a falling knife, and they have fallen for many of these tech giants. And they've also, these tech companies have also begun to lay off their employees. And, with inflation, with the current economic climate, everything that's going on, cost, money, this has been like a recurring motif the past 6 months to a year or so. And even on the technology side of things, there has been trade-offs made in some of these companies like pre-render and Basecamp. Over recently in the DevOps world, there was a movement for migrating to cloud. So, there has been cloud migration taking place at many organizations to adopt, AWS, Azure, GCP. But recently, there has been a few companies doing reverse cloud migration. And because of, the rising cost of cloud services, especially AWS, some of these companies like pre-render and Basecamp especially, that are more on the mid-size in terms of company size, they've been reverting back to using on-premise solution or a hybrid solution, where they're compromising on operations and managing infrastructure for lesser cost. And ultimately, yeah.
Yeah, no, it's definitely it's kind of up in the air right now. I mean, yeah, like you were saying, there are some folks that are finding more benefit of moving away from the cloud and finding that they can save a lot more money if they are able to host their code on their own servers. The amount of money they invest into having to support actual technicians to take care of that might be cheaper than allowing everything to run in the cloud, especially if you don't have folks that are knowledgeable enough about the cost of some of those cloud resources. It can run away really fast, because different cloud providers charge different ways. Like Amazon, I think for some of the EC2 instances, you have to block it off for like a day, whereas like Azure, it's kind of like a pay-as-you-go plan. So I mean, even these different cloud providers have different cost mechanisms that they use. And yeah, depending on if you're like a small company or a big company, it might be beneficial to do some sort of hybrid thing, or utilize the cloud resources when necessary. Yeah, a lot of trade-offs for sure.
Yeah, definitely. No, James is right. Those are all valid points. And ultimately, having to, manage whether it be like, Dell servers or something on premise, there actually has been companies providing like a white glove service type of thing where, they'll help you manage your on-premise, mini data centers. And it is a solution like, Basecamp's pretty popular, but it's something that they're looking to. They haven't fully migrated off to on-premise, but that hybrid solution is where people are moving towards. But yeah, it's going to be interesting to see how this ultimately plays off, later this year as well, as the economy continues to play out. So now, we've seen this. These were some of the primary reasons as to why, it's very important to make sure that we include this tool as part of our development. And InfraCost can basically read into your Terraform plan and provide a breakdown of the cost for the resources that you want to provision. An account is needed to obtain an API key, but there's a free tier available. So anybody can, sign up and get the API key to run this tool. Also, there's several outputs that are available to render out this information. Right now, we're seeing it in a table form here. It could also be an HTML report or JSON as well. And the best part about this is that it's available as a Git hook. So what that means is that, you can now gate commits and PRs from being acceptable if it exceeds a cost threshold. So if, this is pretty big, because now that we have the capability to bring cost into the discussion prior to applying a plan for new resources, it's going to keep cost at the forefront of everything. And, we can have those automated checks to make sure that new changes to infrastructure is rejected if it exceeds the company's budget or any specific threshold for that matter.
Yeah, and it's kind of like more that shifting left, like instead of finding out about it later, let's move it a little bit further left.
Yep, yeah. And with Git hooks, definitely that's a huge one, especially during development. So yeah, I think VS Code also has a plugin as well. It has an extension that's going to, as you define the resource with the settings, it'll inline the cost right above it. So, it's a tool that's well built, super flexible, and, provides a lot of capabilities. I believe Pulumi is still in the works of having this, a feature like this implemented. So currently it's just Terraform that's supported. And yeah, in the screenshot, you can easily see there's several Terraform resources here with its overall calculated cost. And you can see the overall total at the bottom right corner. We're going to use this, and we'll see this in action for the workshop portion of this presentation. And here are some other just very beneficial links that I suggest everyone looks over. First, we have HashiCorp's docs on the, there's the foundations of Terraform. And if you're looking to add it to your arsenal and transform, the infrastructure provisioning via code, it's highly recommended you look it over. We do have some thorough documentation on all the resources and the definition for Terraform for AWS cloud providers. So the second link is an example for that. And their documentation is pretty superior, way better than Pulumi's, in my opinion. Everything's up front with a bunch of examples, and it literally tells you all the inputs and the outputs that you can get for defining each resource. And then for InfraCost, they also got some super useful documentation on using the tool for different scenarios, whether it be CLI or part of CI/CD as well. It also provides a dashboard to store all your calculations on the infrastructure as well, based on your API key. And finally, we have a few interesting articles for some of the companies that we mentioned, and details on why they're moving from cloud providers back to on-premise. So definitely some interesting reads there as well. Any questions before we get to the workshop?
So are you hearing anything like with customers about them wanting to move away from the cloud, or are they still pretty embraced in it?
To be honest, pretty embraced in it. I think a lot of major corporations, it's not a simple task to move from, a it's not a simple task to move an enterprise architecture from a cloud provider back to on-premise. Not only that, definitely for much larger architectures, an on-premise solution would require a ton of, logistics around it, just maintaining those on-premise servers, data centers, or whatever. It was just interesting to see how some of these, it all fits because of the economic climate. It's interesting to see how some of these smaller scale companies, mid-sized level companies, are actually doing the whole reverse cloud migration to give on-premise a try. In some of those ratings, you'll see that they're saving, up to $1 million in cost when it comes to provisioning their architecture.
Yeah, I mean, I imagine there's some trades on that though. So because once you're managing it yourself, you may need to have some staff you didn't have before, or
Yep.
have to look at doing capital expenditures every few years for hardware upgrades, this sort of thing.
Yep, yeah. There are services out there that kind of handles that for you. It is additional cost, but significantly less than the cost of resources for staying on AWS for the long run. And of course, it's case by case. Any other questions?
What other cost tools did you stumble upon when looking up when finding like infra cost? Were there any other tools that you found that were comparable, or that could accomplish some of it, but not everything that infra cost could do?
Honestly, I haven't seen a competitor. InfraCost was something that I know the larger community has adopted. And yeah, that's why, like, I don't think there is anything else with the same capabilities as InfraCost. But yeah, I'm sure it's definitely something that could be built. They are hooking into like AWS APIs, cloud provider APIs to retrieve those information. But it was awesome to see. We'll see it as well at the workshop. It's very thorough in terms of providing everything you need for seeing the cost of all your resources.
Nice.
All right. So for this workshop, the prerequisites will require an AWS access key ID and AWS secret access key. Also, Terraform 1.4.0 or greater. We aren't doing anything super fancy with Terraform, so if you do have a lower version, that should suffice as well. And also, you will need an API key from InfraCost. They'll require you to create an account, but a free tier is available, so anybody can, just sign up and retrieve the API key to use. And Python as well. If you followed along James' workshop, you might already have this installed. Basically what we're going to use is Python's pre-commit package. It's pretty useful. And what we're going to do is first we'll set up an S3 backend to manage our Terraform state. This is an S3 backend is not required. I'll also show how to do it with the local backend. That way, it's much more simpler. And then we're going to define a resource we want to provision. Well, for this workshop, we're going to create an S3 resource. We'll do something similar on creating a static website. And then we're going to set up the pre-commit hooks for InfraCost. And I'll kind of show you the InfraCost portal, how we can set it up as a pre-commit hook, and even on a pull request, what that looks like. And finally, we'll apply the definition and make sure it applies to our infrastructure. So I'm going to share. So just a heads up, we do have this available at a public organization or public project InRhythm workshops. We do have the Terraform. James repository is also available there, Pulumi with Python. We do have Terraform InfraCost. A repository is all set up with various steps. We have a step 1 setup. This is going to use a local backend. We have a step 1 set up with S3. And we also have step 2, which is we're going to implement some of the static hosting settings that are needed for setting up S3. And then finally, we have a branch for step 3, which is we're going to test out InfraCost. Yeah, so feel free to follow along, check out any of these branches, and I will get started. And I'm just going to delete some of these to ensure that I'm starting from scratch. Okay, if you guys are using the AWS CLI, feel free to set your profile, make sure that the keys that you want to use is in context. That way, when we do run the plan and the apply, everything is going to run correctly. So you can simply do export AWS access key ID equals your value, or AWS secret access key equals the value for your AWS secret. I just configured my profile. I do have the AWS CLI set up, so I'm just setting the profile for the AWS account that I want to use. Okay, the first thing you want to do is create your main. And this is pretty much going to hold your resources. And as we mentioned, we are going to create our S3 bucket. I do have, if you're using VS Code, there are tools there is an extension for using Terraform. So you get code snippets and auto completion. That makes it even further helpful, especially for someone, especially if you're someone who's fresh with HashiCorp's configuration language, the auto populate definitely helps. So the first thing we're going to do is configure a AWS S3 bucket. So in the event you guys are also following along, we all can't have the same bucket name IR workshop. So I'm also going to create a resource for generating a random string. Let's say it's going to be just 6 extra characters. We'll also include that. And as I kind of said in the presentation, these resources export and output values as well. So I can simply use those in other resource definitions. So I created a bucket. S3 also has a flag for destroying, force destroying it, because if the contents of AWS S3 bucket is not empty, it can't be destroyed. So this force destroy is going to help with that. And that's my AWS S3 bucket. One thing I forgot is setting up the Terraform backend. So let me create a backend.tf for that. And this is just going to be Terraform backend. It's going to be, let's do a local backend with a quick demo. So this represents the state file that I'm about to create. It's a brand new project, so I do need to initialize it. Once I initialize it, it's going to create a terraform.tf state file by default. So right now I'm initializing it. The source code that we do have available on InRhythm workshops, I'm just going to look over. There's this .github directory with workflows. There is a predefined CI/CD configuration. We're going to look at how Terraform uses CI/CD as well, especially when it ties in with InfraCost. And we also have a pre-commit configuration file. So Python was a required dependency. We're using the pre-commit package, and the pre-commit package takes in a config file where then once you run the pre-commit installation, it's going to create Git hooks for all these pre-commit tools. And this is a very popular pre-commit library available, pre-commit Terraform. This is what I'm using. It includes several pre-commit hooks that's going to be used, especially when using InfraCost. So I have my Terraform initialized. As we saw in the presentation, we first initialized. I don't have any existing resource, so I don't need to import anything. So it's just going to be plan and apply for me. Terraform plan. Here is similar as we saw for Pulumi. Details are returned for your plan. This is pretty much a dry run. It shows you what is going to be created. We have the AWS S3 bucket workshop created. And we also have this random ID generator resource created. This random ID generator returns these outputs, and hex is what I'm using to just give me a string. So it's going to be IR workshop dash some string. And as you can see, it says known after apply. So we're going to run that. Apply. Oh, and it asks me, do you want to perform these actions? Yes. That's it. It's been created. Let me show where that is. Okay, so our new AWS S3 bucket has been created. Let me just verify. Yep. ID equals IR workshop 4B1, etc. And that is what we have here. So our S3 bucket has been provisioned. So now let's continue on. This is pretty much the end of the step one. There is a step one with the S3 backend. Afterwards, I'll quickly go over that. There is more configuration needed for that, but it will help you set up a centralized state file. So not only you, but other peer engineers can also work on the same infrastructure as code and provision to the same system architecture. All right, so next up, we're going to now create the policy and convert this bucket to convert it so that it supports static web hosting. So the first thing we'll need to do, let's add a configuration for this. And all of these are ultimately, this is where I'm going to be pulling it from, registry. See, the documentation it's very thorough here. You can simply documentation. This is the main AWS documentation site. Just type in S3 bucket, all the information you need, example usage, argument reference, attributes reference, all laid out here. And a lot of these includes the most common use cases that everybody use when it comes to provisioning these resources. So I'll be working off of this for those that are following. So let's create a website configuration for our S3 bucket. There it is, website configuration. So the same name, as there's only one resource of this. And the bucket, I will provide the value that gets exported. So it's going to be AWS S3 bucket dot resource name dot ID. And we need to provide the index document, what file it is. It'll just be the index.html and an error document. So that if somebody attempts to access a path that doesn't exist, it's gonna land them on this HTML page. Right, so I have my website configuration. All this is going to do is it's going to go into properties, static web hosting. It's just going to enable it. It's going to enable it, and it's going to set these two values. So that's what I defined via code just now. However, that's not enough to allow me to have people access the site. I do need to add the JSON policy to give it permissions. So let's go back to the code. Okay. So usually when we define data or JSON, we can put it into a data.tf file for anything that's data related. Here in our main, you see all of these are prefixed with resource. We're going to use data here. And all it's going to be is a Terraform resource that points to the JSON policy that I'm going to be attaching to the S3 bucket. So data, it's an IAM policy. Right, and this is similar to the JSON policy that Jane showed, but it's going to be in Terraform code. So it's not flat out direct JSON. Actions. We have the only action that we're going to allow is getting the object. So we're going to allow principles. We don't have anything specific, right? So, and the resources that this policy is for. So it's just going to point to the ARN. There's three columns there. And so I need to specify the AWS bucket name. As I said before, it's just going to take the resource name and the exported value. So that's exactly what I'm going to provide here. Right. That's strange. All right, let me see. I'll get back to this, but I'm gonna have to see if that builds. Okay, so now that I created my JSON policy, I'm going to continue to attach. I need to attach the JSON policy to my bucket. So AWS okay. Policy. So this resource is going to handle attaching those two. I'm going to define the reference to the bucket. Oops, that's not AWS. AWS bucket. Yep, that's fine. And the policy. Since it's a data type, we're going to start it prefixed with data. And just going to use this. Is the name of the data and the reference. Okay. and it's a JSON output. Okay, so we've enabled our S3 bucket for static web hosting. We've created a JSON policy and we've attached it. All that's left is there's one more resource we need to create, basically defining the ownership controls of the AWS S3 bucket, which will be only to the owner of the bucket and nobody else. Same thing, it needs to point to a bucket, so I'm going to use the bucket that we defined. And and that's the setting that you see. Some permissions. Object ownership. So we've basically set the setting, we've set the bucket policy, and because it's static web hosting, it's open for public. So let's now apply these. We're going to do a quick dry run. Okay, so it doesn't. Should be it.
I think it might be line 4. Should that curly bracket? Maybe.
Oh, I see. Yeah, you're right. I closed it too early. This entire thing is the statement. Oh no. Okay, so James, I know if you look at your JSON, what am I missing?
Yeah, let me pull up the repo here real quick. So you got the
principles isn't an array. I think it's an object.
Yeah, yep. That was it.
Oh, okay. Okay, got it.
Didn't
All
work.
right. Yeah. All right. So let's run the plan for that. Whoops. AWS bucket. Yes, that's incorrect. There's no such thing. It's AWS S3 bucket. This is why running the plan is helpful before applying, especially in your CI/CD pipeline. You want to make sure the dry run catches failures before you actually execute the plan. Oops, more mistakes. Principles. Oh, it's an object. It doesn't need the equals there. Okay. So as you can see, 3 more resources are being created: the ownership control settings, the bucket policy, and enabling it for static hosting. So going to Terraform apply, just going to pass the auto through. All right. Okay, while it's creating, as you can see, this is the local Terraform state, similar to Pulumi. We do have a full-on contiguous JSON file of all the resources that were defined, and all of its settings and all the configuration and everything. And this is gonna take a minute. And once we next, once this is finished, we're gonna take a look at how we can use this with InfoCost. So S3 bucket is cheap, especially for something like this. There's nothing that we really created. So the cost might show up, usually rounds, I think, but it might come up as 0. Putting malformed policy action does not apply to any resources. Hence the... All right. All right, James, help me out here. Definitely missing something. Got the principles.
Not applied to any resources. Supposed to be
Resources. Oh, it's everything under the bucket. Let me see if that.
data.
Yes, yeah.
That's it.
So I was missing that slash asterisk. This means that everything under this bucket will get this policy applied, and that's what we want.
Nice.
Okay, so it was applied. And let's see properties. Yep, static web hosting is enabled, bucket hosting is there. And we have a URL there. Let me upload index. Sorry, give me 1 second. Looking for an index.html I can throw on there. Alrighty. Just putting an index.html in there. I'm gonna upload that. And if I click this URL, yep, cool. We were able to set up the S3 website via Terraform. All right, great. So now let's take a look at InfoCost. So InfoCost requires an account. These meeting controls. Okay. Okay, cool. You can sign up for InfoCost if you go to infocost.io /docs or infocost.io at the main homepage. It should take you to the homepage where you can sign up for a API key. So once you have that API key, it's gonna follow alongside the docs here. You can infocost.io /docs, very straightforward if you're using Mac or Linux. I've already installed it, curled this into my machine, and have this running. Version 0.10.18, it's there available. And you can get the API key. Once you create an account, you can run InfoCost auth login, and when the callback comes back to your terminal, you can run configure get API key, and it's going to be applied. It'll basically create like a home directory. Within your home directory, it's going to create like its own credentials file, similar to how AWS does it, and the API key will be stored there. So this is all it is. It's a matter of just running this command on the CLI, InfoCost breakdown --path. Going to paste that in there, and voila. AWS S3 bucket.ira workshop. These are the configurations I have for it. This is what's been scanned on that resource. And as you can see, it's close to $0. I do have, my main branch does have Elastic Beanstalk provision to kind of see more of, that's something much more pricier. And so we can see like a delta and a shift in cost. So we will take a look at that afterwards. So as a pre-commit hook, just to show you, I'm going to add all this. As I mentioned, this pre-commit package is from Python. You can run pre-commit install. And as you can see, it installs all your Git hooks into the pre-commit Git hooks directory. Into the hooks directory for pre-commit. And these are all the libraries I'm using. Some of these are, this is a linter. Chekhov, I believe, checks for vulnerabilities. There's another linter. Have this commented out. Validate. Validate's going to also do a quick dry run before committing your code. Also docs. I'm generating documentation before I commit. All you need to do is in the README, you'll see that there's markers for the beginning of the pre-commit docs hook and the end of the pre-commit docs hook, and it'll basically output documentation for you as you make changes to your code. And finally, info cost breakdown. So this pre-commit hook is actually going to use info cost, and the arguments I mentioned was the plan file, the JSON output of it. It will also create an infocost.json file if you need to refer to it later on. And as part of the hook, you can provide thresholds and other configurations. So the currency we're using is USD, and the threshold we have is the overall total monthly cost has to be less than equal to $10. So it passes. Now let's going to just formatting failed. As you can see, it failed, but it automatically formats it for you right before you commit. So, you know, that's a beauty in itself. You just write your code, and right before you commit, it's going to clean it up for you. So I'm going to re-add all of those files. Runs validate after that. Docs failed as well because there were new resources generated. So as you can see, it just updated the documentation for me as well between those markers. I didn't have to do anything. So going to run it one more time. Okay, info cost breakdown. It passed. Obviously, the cost as we saw when we ran it from the CLI, it was 0. So it was $0. So with when we look at the Elastic Beanstalk example, we'll see more of exactly how this can be used to kind of gauge your commits. So let's take a look at the info cost dashboard. So I already have a repository pre-configured. That's the Terraform info cost repository that's in the InRhythm workshop. You can connect your repo as in, you can connect your repo as an app. It'll prompt you to log in via GitHub. So you can, so that way InfoCost can apply, it can run InfoCost on your pull request when you raise them. So I do have an example of that. I have a pull request open here. So as you can see, the author of this comment was InfraCost because I've connected it, and it's showing me a delta of 17 bucks. And this is off the main branch, which I'm going to show has Elastic Beanstalk on it configured. It does provide a very thorough breakdown of all the resources that's being used and the cost for it as well. Here are the number of resources and the overall cost. Originally, it was $54, and this commit actually introduces a secondary Elastic Beanstalk application as well. So because now I'll have two, which I'll show in a bit, the cost went up $17. So super informative. You know, developers can collaborate on this and, you know, make their judgment on whether to approve the PR based on this context alone. So just to quickly. So if we take a look at this, there's this one is a more developed sample architecture that I have on the main branch. It does originally start with the S3 setup, and I've converted it into a module because all those resources that we defined could be pre-configured as a single module. So anytime I want to provision an S3 website, I can just import that module I created, and provide the necessary flags for it. So if I want to customize the domain name, I can add a variable to configure that. I can add tags. These are used mostly for bookkeeping when it comes to resources. But this S3 module has everything we defined just several minutes ago. All right. I also have a VPC on this since I'm creating Elastic Beanstalk. Just want to make sure that it's isolated within its own space. And the Elastic Beanstalk, this looks like a very dense implementation, but all it is there's an app. As I mentioned, there's two parts to Elastic Beanstalk. There's the application, and within the application, you can have several environments. And the environment is created here. It's a Node.js environment, and there's a bunch of configuration right underneath it as well. And this specifies, you know, whether there needs to be a load balancer, you know, the number of instances needed for your Elastic Beanstalk, any other Elastic Beanstalk configuration that you would see from the GUI can be set here. Elastic Beanstalk is a pricier solution compared to other alternatives, especially if you're trying to just host an index.html page. So let's bring InfraCost into this. InfraCost breakdown. So we get the whole breakdown for on a monthly basis. That's actually what I had configured. It's a monthly breakdown. So as you can see, about $71. Now I'm going to try and commit this. Oh, I don't have, so I'm going to add a new Elastic Beanstalk environment. I'll call it EB workshop. Whoops. Because anytime you add a new module, you need to make sure you do Terraform in it so it can install any dependencies required for that module. Because I've been shifting around, I switched out branches, so the Terraform state has actually changed. So it picks up on that and it tells you backend configuration change and throws an error. So I'm going to reconfigure it. Yes. Actually, let's stick to the local state. No docs, because I added EB Workshop 3, the docs were updated. Okay, yeah, that didn't work, of course. Let's see, config. Put plan. Oh, that's because it's looking at plan.json lips. Okay, so we have provided a super small shell script to generate a plan and then convert that plan to JSON. Regular Terraform commands, you can also just run this, but just for the for making things easier, I will run this to plan. So it's running Terraform plan again. This time it's going to take the plan output file and convert it into JSON, which is what InfraCost can read. So that makes sense. You know, I've created a new Elastic Beanstalk environment. So I need it as part of the plan file to, you know, figure out all the resources I'll be creating. And InfraCost is going to take that delta, the newly added files, and calculate the cost based on that. Let me bring that change back. Okay, I'm definitely missing. All right. We need to debug a little. Let's see about this. Input cost breakdown. Going to use plan.json that I just created. Okay, $88. Yeah, makes sense. Maybe it's this out file. Okay. Yeah. Yeah, it can, I think it reads either from the path that you provide or the InfoCost file, if it exists. I do have an InfoCost file, but it could be stale. So yeah, removing that fixed it. And as we can see, $10 is my threshold. That's all I got. And the total cost of my resources is $88, a delta of $36 increase. And yeah, it's not, it failed. It prevented me from committing its status. My files are still there. So as you can see, this can be used to kind of gate, to really gate your code and ensure that, you're always thinking about cost. Do I need to provision a NAT gateway? Can some other, means help in achieving connectivity? Do I need to use Elastic Beanstalk for a simple static website? Can I just use an S3 bucket? So these are all the things that come into play. As long as you pre-configure the settings for, all everything that you want to gate. As you can see, there's also number of resources. If you're creating too many resources, I can block you based on that. Cost, there's also, I think, weekly cost as well, daily cost as well. So there's a ton of flags and a ton of flexibility to keep cost, the focus of and when provisioning code, when provisioning infrastructure. So super powerful tool, and it's definitely useful. I think, especially with everything going on in today's world, this is something that we'll see more and more adoption of.
Now this is awesome, especially so, in the past, the cloud providers have their own, centers for tracking costs and everything like that. Each cloud provider's got that, but to be able to incorporate it into your CI process, be able to, like you said, be able to gatekeep resources or PRs based on, cost, how many resources they're deploying. Like this is really cool.
Yep. Any questions? Does anybody want to share if they've been following along? Any problems you guys ran into, or if you want to share any of your experiences around this.
I did run into one issue. I think it's something on my side, just not configuring it properly. Whenever I was trying to configure my AWS credentials, I think it might just be conflicting with something I did previously. But every time I would do a Terraform apply or anything, it would request me to re-input my AWS credentials. So that's on my side though.
Yeah, you can use AWS configure if you're using the CLI. You can run AWS configure to put your credentials into so with the CLI, there is a directory that gets created in your home directory .aws, and the credentials get stored there, and you can have your credentials assigned to specific profiles. So that way, you can kind of toggle between different AWS credentials within the context of your terminal.
Nice.
Any other questions?
Yeah, I don't have any questions. It just took me a little while to get my AWS going and figure out that whole config file and all that. But actually, I do have one question. What are you guys by chance going to add back to the repo like a step-by-step instructions on like what the running through each piece by chance?
Yeah, so the repository does have separate branches for
Yep.
each of the steps. Step 1 setup is for setting up a local backend. There's the S3, the static hosting stuff we did where we added the bucket policy and some of the settings for the S3 bucket. You can find that on that branch. and step 3 has running it with InfoCost. We can definitely add a little bit more documentation in each of these branches, so you kind of know the current state of the code and what you can do to make changes. So yeah, I think that's something we can take on afterwards.
Okay, thanks.
Alrighty. So we will be back in another 10 minutes. Yeah, we'll be back in 10 minutes, and next we'll talk about Backstage, and we're going to pretty much attempt to connect everything that we just did and look at another way of provisioning infrastructure as well. All right, let's get started. So Backstage has been open sourced by Spotify and is actually a new developer portal experience to kind of help centralize all types of resources for an organization. I'm pretty passionate about this. It's going to be super exciting to see the capabilities of this. So let's check it out. So we're going to start by saying the current ecosystem of platforms as a service and how infrastructure provisioning works today, pretty much. We'll then see what Backstage can do for us in terms of unlocking self-servicing capabilities. So we've seen originally there was a manual process of kind of going into the GUI, creating the S3 bucket. That's how many organizations were doing it back then. Over to transitioning to more infrastructure as code. So now maintaining it similar to source code using version control. Now we're going to see how we can bring that into a developer portal where engineers can go in and self-service whatever resource it is that they need. So a question for you guys, like, how was infrastructure being handled across organizations in the past and today? And like James, what is your experience with how infrastructure was provisioned in some of the past organizations that you worked at?
Yeah. So the last job that I had, it was a Microsoft shop, everything Azure. And yeah, I mean, before I left, we were just getting to the point of starting to work with Terraform, but yeah, it was all manually done through ARM templates. I mean, it was pretty, like you said, you really had to know what you're doing, and it was definitely a very tedious, manual driven process for sure. And so that's, yeah, infrastructure as code, being able to define it within a file and then just run it and have it take care of it for you, definitely alleviates a lot of that confusion, misconfiguration, things of that nature that, and it's a lot faster. I mean, you save so much time.
And also,
Yeah.
otherwise, like each and every environment is like building a new environment from scratch. So each and every environment is different. Like we have all seen so much of time being wasted on some code is working properly on one environment and on the other, to find out that hey, some infrastructure was not the same. So
No, that's a very good point, especially with folks that do maintain different environments like QA environment, UAT, production. You want to make sure that those environments are at like that are spot on. You don't want anything misconfigured because yeah, just like a bug, you have a bug that gets into the system, the amount of time, money, resources that you have to throw at it to get it fixed. I mean, it's similar to a misconfigured environment. You're wasting time, you're wasting resources, which eventually results into wasting money. So
Exactly.
Yeah.
And it actually gets worse, when in some, very large enterprise organizations, you don't really have access to, you know, being able to contribute and, you know, sometimes even assist with the infrastructure as code side of things. Not all engineers. Maybe if you're DevOps, you do. But some of these large organizations were, you know, they have something as simple as like a ServiceNow ticketing system. You know, you need to put in your request, you know, to get infrastructure provisioned. And that itself takes, you know, several days just to, you know, get up into the queue and then being accepted by somebody through Jira and being assigned to an engineer and then, you know, getting it provisioned. So, you know, that's like the one downside to this is that the turnaround time, you know, from sending the request to having your infrastructure provisioned, especially for large enterprises, has been, you know, a common problem.
It's kind of like moving the bottleneck from one area to another area. It's like
Yeah.
now you're kind of bottlenecked and waiting for things to be provisioned for it.
Yeah. And it's ultimately it's a cultural and a process issue as well. And on the flip side, like often at startups and smaller size companies, um, you know, usually they might not necessarily have infrastructure as code in place. You know, there might be a senior engineer or a single engineer for say like a 10-man startup, you know, that'll actually go into AWS, use the GUI to provision, you know, whatever simple architecture they need for their startup application. So, you know, with all these different common workflows, um, we're going to see ultimately how this plays in and how Backstage is actually going to help solve and eliminate, if not all, of these common workflow problems that we have today. Okay, so simplifying infrastructure for application developers. As we know, platform as a service is a model that can help provide a means to provisioning cloud infrastructure and resources without the complexities. So some common examples are actually, if we look at some popular past tools, Heroku or AWS Elastic Beanstalk, these are pretty much just wrappers over, you know, AWS EC2 instances. Takes away the need to understand how to configure all the settings, how to provide, you know, network related configurations, all these kind of things. A service like Heroku, a platform as a service like Heroku eliminates all of that. You know, you just click on what you need, deploy your application to it, and it's good to go. Elastic Beanstalk also provides something similar as well. And with platform as a service, you know, nowadays, because of platform as a service, there's now platform engineering. And this approach is what's going to help provide a portal or a single destination for, you know, everybody within an internal organization to come in and fetch or get whatever resource they need available to the organization. So, and this in turn provides self-servicing capabilities. You know, I no longer need to create an entire ticket for it. You know, there's an entire pipeline on the back end ready for me when I simply click a button for provisioning, you know, whatever resource it is that I need. And it also allows for cataloging internally, kind of as we mentioned. And ultimately what that's going to do is really increase discoverability. So one key thing for super large enterprises is that there's always that issue where there's many different teams all working on different products, but definitely overlaps between them. And you know, whether it be a microservice, whether it be some sort of tool, and you know, what happens, what commonly happens is that developers end up rebuilding or reinventing the wheel for some of these internal services that already exist for other teams, but we ended up rebuilding it simply because we didn't know about it. So what Backstage is going to do is really bring discoverability to the forefront and ensure that every engineer can visibly see what's available to them, what kind of repositories, what kind of resources are available to them. If it's not what they want, it's something they can probably work off or implement. And this ultimately fosters a culture of inner sourcing. So more people, they'll continue to improve the products that already exist rather than, reinventing the same microservice, the same tool for their own needs. And then finally, it also, because there's that central portal to every single resources, it ultimately enforces standardization. So because everybody's provisioning the same exact type of resource. So if I wanted to have an internal Node.js app backend application hooked up to CommitLint, lint staged, that has pre-commit hooks, semantic versioning, change logging, any files with metadata that's related to the organization, licenses, I can have all that in a boilerplate project, and anybody who needs to create a Node.js backend app can simply provision their repository from that same exact boilerplate. And ultimately, there's a standard in place because of that.
Oh, that's very true. Like, just from working, at past large companies, enterprise level, yeah, it gets to be, I've seen it before where it gets to be so big that it's hard. It sometimes it's like the left hand doesn't know what the right hand's doing, and so you got, sometimes multiple teams working on the same thing at the same time, or maybe somebody might be recreating a wheel that was just created over here, and yeah, having like a centralized location for these types of resources would definitely help alleviate a lot of that confusion, and like you said, foster that discoverability, reusability, that teamwork, aspect, working, sharing the collective knowledge.
Yeah, no, exactly. Now let's take a look at the platform that's going to actually provide us all these capabilities, which is going to be Backstage. So Backstage, as I mentioned, it was a tool open sourced by Spotify. It's a robust, ready-to-go developer portal, and it's actually written in React. So what this ultimately does is that a tool like this actually brings developers and DevOps together in a way where developers are going to help DevOps set up DevOps for the organization. So a tool like this, because of platform engineering, it really bridges developers and DevOps together. There's no longer the whole silo of these two teams where, you throw in a request, wait a few days, get the response back later for whatever resource it is that you're trying to have DevOps create for you. So this is definitely a tool that fosters collaboration and helps bring those two aspects of development together. Simply put, Backstage is literally the app store for all the services and tools that are going to be available internally within your organization. The developer portal that we're going to see in our workshop later provides like a full-fledged portal with these cards that kind of provide a seamless, easy to understand GUI for getting the tool or service that you need. And once you pick an offering, you might be prompted to fill out a form for some metadata, like the name of the application, the name of the repo, and then it's good to go within several seconds to minutes, depending on how extended the pipeline is. And these choose buttons ultimately hook into the backend and could be connected to webhooks, CI/CD processes that allows for full end-to-end servicing. So like, for example, I can click on this CRA template right here, and it'll provide a new repository for me on a source code management platform of the organization's choosing. And once that repo's been deployed, I could have like a DNS configured, and I can even have that resource deployed to an S3 bucket, so it can be accessed right away. And all of this can be chained just by simply, selecting choose and filling out the form that comes right after. So as we can see, it kind of provides a full beginning to end automated servicing mechanism that's going to eliminate the need for wait times, ticketing systems, and any of that when it comes to, just getting the resources that you need to get your work done. So for what Backstage ultimately allows is the standardization of resources to make sure that it fits within the organization's rules, regulations, and industry best practices as well. And with Backstage, we can create these boilerplates that are internally agreed upon in terms of the structure of it, the folder structure, all the tooling related to it that's going to provide the engineers for an optimal developer experience. So I can basically take a sample boilerplate that includes probably like a Django starter app or a Node.js app and hook it up with, all the tools, as I mentioned, linters, commitlint, all of that, licenses, and everybody who comes into Backstage can provision that same structure, that same standard, all the same tools every single time for the technology of their choosing. And on top of that, since we can configure these boilerplates, we can also add CI/CD to it. We can add CI/CD configurations to it, and that can be standardized as well, so that you can really hit the ground running. This eliminates the need for any of that, repository setup or, configuration. Hit the ground running, focus on business logic, focus on building out the application or service that you need. And ultimately, this allows for cataloging. And once you have a catalog of all these resources available to you, it really allows for discoverability on the organization level to see everything that's available out there internally to really, fit your use case, to fit whatever need it is that you have. And like one common case that we mentioned was, developers often need to dig out to see what other teams have implemented. If they've implemented something similar to what they're trying to build out, sometimes they always need to like search rigorously through Confluence to see if they can find any information. And ultimately what they find is, how to set up, for example, how to set up a Node.js app, a guide on how to set up a Node.js app written differently with different instructions across 3 different teams. So to avoid these kind of situations, having that discoverability and centralization of all resources and anything you need is definitely a huge win for the organization. And of course, ultimately, because you now have access to see everything available to you, it allows for more composable architectures where you can, leverage other things that have been built and really improve those resources that already exist and work with them. Here are some useful links. So the first 3 links are for Backstage. It provides pretty thorough documentation. As mentioned, it's been open sourced by Spotify. There's and it was so one disclaimer actually is that because it's been it's very new. It's been released in 2020, so you will feel the effects of it. There's definitely still issues out there, but it is a web-based application, so anything missing, you know, the open source community for this is huge. So you can definitely, you know, build your own plugins, contribute, and really, you know, help Backstage grow. So these three links, the first one is the main documentation to kind of see what exactly it does. The second link will provide you a getting started guide. And the third one is a demo of what Backstage looks like, what a catalog looks like. And for regarding platform engineering, this is really a new shift within the DevOps world to, you know, help bridge the gap between developers and developer operations and just kind of provide that centralized portal for internal organizations. Netflix is already on it. Wayfair also uses it. So there is a lot of large companies that are moving to this shift in mindset and process. There are other competitors out there, Ops Level and Cortex. Both of them are paid services, and yeah, those definitely, you know, they do provide customer support and a bunch of other tooling that's available just for those as well. They don't have the flexibility of open source, so you know it's not as configurable as Backstage, where you can create your own scaffolder, create your own plugin, and have the community use it. So yeah, we'll see how all of this plays out and what it looks like in our workshop next. Before we get started, any questions?
So are you saying that Netflix is using Backstage as well, or
Yep. Netflix is also using Backstage. Yep.
no? I think when you see companies like that, you know, like you said, Backstage is pretty new, and I know a lot of big companies are pretty hesitant on using like new technologies, but when they do, I think, you know, that also kind of says something as far as like what the product offers and how like, yeah, and the impact that it can have. So that's cool hearing that you know, Netflix, and you said Wayfair was also using Backstage as well.
Yep. Yeah.
That's cool.
It's definitely there. I haven't seen any other large open source competitors. A lot of the tools that are available are paid services. So this is it definitely has a lot of potential, and 100% I see it being adopted across more organizations this year itself and in the future.
Well, in that open source aspect of software too, especially whenever you start getting into those larger organizations, you know, because it's being exposed to more developers, you know, I think you'd have like, you know, a better chance of it being improved by those individuals that are using it as well. So it's kind of like, you know, kind of helps further make it more stable, I guess you'd say, you know. So
yeah, adopters of Backstage, you know, they definitely they can contribute to the Backstage application itself by creating plugins and whatnot. Not only that, Backstage itself fosters, you know, inner sourcing because of the discoverability capabilities. If an organization decides to adopt this, it definitely brings that forward, and you know, more people will contribute to what already exists out there. So it's definitely a cultural and a process win as well. All right, we'll get started on the workshop. So for this part of the workshop, it can be a bit overwhelming. As I mentioned, it's a React-based application. There is a lot going on. But yeah, I'll definitely hold your hand through it if you guys need. And so for the prerequisites, a Node.js environment is required, and a GitHub personal access token, or an access token for any source code management provider you want to use. So GitLab works just as fine. So basically what we're going to do is create a new Backstage application. We'll be using Yarn to do that. Then we're actually going to connect to a source control management system. What this is going to help do is pull in all the repositories that are configured for Backstage into the system. So this is where the discoverability this is where we'll see the discoverability access aspect of it. And then we'll see how we can also hook in our GitHub Actions as well to trigger CI/CD from Backstage. And yeah, we're also going to look into some templating as well at the very end to kind of see how we can enforce standards for the internal organization. All right. Okay, going to. All right, I'm sharing my terminal and sorry, desktop. All right, feel free to tag along. Let me just show where this is available. Once again, you guys can go to our InRhythm workshops on GitHub. Go to repositories. We have Backstage demo here. This also has been configured similarly to the Terraform project, where the step one is going to be simple initialization. Step two, we're going to look at the discovery aspect of it, pull in repositories. And step three, we're just going to look at some of the templates to enforce standardization. Any point, if you get stuck, just feel free to check out that respective branch, and you can continue on from there. So we will start by provisioning the application. So it's using npx, which comes from Node package manager. npx basically lets you install packages without having an a local npm configuration. So I'm creating Backstage using the create app library, and it's gonna basically prompt me for a few inputs. So this is gonna be the name of the project. Backstage. Yarn not found. Whoops. Make sure, as a prerequisite, I did mention that we need version 14. The latest is 18 right now for Node. It's up to you what version you want, but I think it's safe to be anywhere above 14 should be fine. So I'm just going to use the latest. Of course. I'm putting the name, it's installing, it uses Yarn as the package manager. So you will need that installed. Okay, it seems like it's taken quite a minute. There are a ton of plugins. It's a pretty large application. Oh, and for the backend, it does record all the settings and records, stores it into an in-memory database, SQLite, but it can be configured to use any SQL Server data, any SQL-based databases, relational databases. So Postgres, they have configuration settings for Postgres, SQL Server. Yeah, especially when it comes to deploying this live, that's something you would want to consider using. And should be done any minute now. And because it's a web-based application, you can reskin it. You can add themes to it. You know, you can change the entire look and feel of it to fit your organization's DLS, to make sure that, you know, it fits whatever standards you have in place when it comes to design. So all of those are definitely possible with this. Okay.
Real quick,
the-
so this
yeah.
this was from that command, the npx at backstage create app. Is this?
Yeah.
All right, I was
Yes.
catching up. I was just making sure I was.
Yeah, no worries. The documentation also is pretty thorough. Yeah. Okay, I'm going to use the checked out branch in the meantime. All right, so, okay, it's been created. Let's open that up. Okay, so my project has been created now. Just gonna quickly go over the directory structure. The configuration is where Backstage's main config lives. This defines organization name, titles, URLs of the application, backend URL, database configurations, integrations, providers, proxy. Backstage also provides Markdown documentation capabilities. So this is a useful feature as well. Authentication providers and catalogs. So to have Backstage pull in a repository, a catalog info.yaml file needs to be defined within the project. So if we take a look at Terraform InfraCost, we had this catalog-info.yaml. This provides some Backstage definition for exactly what this tool or service is. And that's defined using a kind entity. And this, we're calling it a component, as well as it takes a name, description, and an annotation. The annotation specifically for GitHub will be this GitHub annotation that refers to the path of the project. So organization name / name of the project. And these are some boilerplate metadata that we have in place. But the documentation will provide more details in terms of some RBAC related capabilities. There's a full RBAC system, role-based access control, that can be used and defined to list out and specify, who the owner of, repository is, who the owner of resources are. So yeah, for Backstage to pull in your repository, this catalog-info.yaml file is required. That's the only kind of prerequisite for having Backstage discover all the repositories within your organization. Let's see, Pulumi about Python also has one. It's of type component, also got its slug defined, the annotations, and example description. So we'll see this in action. All right. So this is app-config.yaml is the main configuration. There's also a local file. And in this local file is where you're going to define your GitHub personal access token, your GitLab personal access token. So let me lay that out right now. So you're going to have an integrations block. Inside of that has a property GitHub and a property host. The host is just going to be github.com, and the token is going to be your GitHub token. You will place the actual value of the token here. This is a local YAML file, so it's not version controlled. So no need to worry about your secrets being accidentally committed into source control. So for the purposes of this workshop, you'll just need GitHub or GitLab. If you're using GitLab, it would be the same thing. Just using GitLab instead of GitHub. And auth, you need to provide some auth configuration as well. We're not specifying any specific environment, so we'll just leave it as production. And the providers we're going to have is going to be GitHub. For my case, you can switch that to GitLab if it's yours. The environment that's being used is production, as we mentioned. And here, so you will need to create a GitHub app. Let's see how that's done. So you can go into your settings here, go into applications, and go into, let me see, I'm gonna create. So underneath this organization account, you have GitHub apps here. You'll just click on that. And as you can see, we actually allowed InfoCost for that, so they can comment on our pull request. So we are going to add one. Apologies, looking at, what did I do that? There we go. It's authorized. Sorry. Developer settings. You want to go into your developer settings. At the very bottom, there's developer settings. Click on GitHub apps there. And on the top, you should be able to click on new GitHub app. Click on new GitHub app, provide the name, the description, the URL, and the callback URL. The callback URL is actually going to be fetch that. and then you need to look at what I've already configured. HTML. Give me 1 second, this should be defined. All right, let's check the documentation. And that means there we go. Okay. All right, so create an OAuth app on GitHub. We're going to, the callback URL is going to be localhost 7007. That's the port that the backend is running on, /API/auth/GitHub/handler/frame. This will be the authorization callback URL that you need. Ultimately, this app is going to be used when it's pulling in all the repositories from GitHub. So you can add that to the callback URL. And the homepage URL is just localhost 3000. Once you do configure it, you're going to get a, skip the optional. Yeah, once you create it, it's going to, actually, let me just do it now for those that are following along. And of course, it's pointing to localhost, so just make sure you revoke those access once you're done. This is where it is. Oh, okay, I take that back. It's not, it's an OAuth app that you want to create from developer settings. So just to redo that, you go to your organization, you go to developer settings, it's an OAuth app. I have it created on my personal account, which is why it didn't show up. And of course, I was confused. So it's on my personal account, the OAuth application. And so you want to click new OAuth app at the top right corner. It's a much smaller form. Backstage live demo, homepage URL. Oh no, that's the callback URL. Homepage is just 3000. And that's it, register application. And as you can see, I've created this, and here's my client ID. That is where you go, what you're going to put inside your YAML for client ID. And then there's client secret. So I'm just going to generate a new client secret. Obviously, revoke, delete once done. And I have my authentication provider configured and my GitHub integration in place now, all defined in the local config. All right. That's pretty much it for Backstage configuration. So within packages, you're going to see there's three directories of interest here. There's the packages, which contains the front-end application and the back-end application of Backstage. There's examples here. We're going to get into this the last part. This is where you can set up your templates, your boilerplates. And finally, there's plugins. And these are custom plugins if you want to create any to be used within your Backstage application. So let's run this. We have configured our local configuration. Let's run the application now. See what this looks like. Right, it's going to take the application. Okay, there it is. Okay, as part of the boilerplate, so just to start with, this is Backstage. This is the developer portal. On the left, we have off the shelf, working navigation. The home is going to be a list of all the entities, all the types of resources you have. You can have APIs, components, templates, users. As I mentioned, there's role-based access control available here, and locations are reference pointers to exactly where some of these templates live. So that's the home, and there's an API section, a list of all the API. If a project has been defined with the entity of API, it'll render out here. So by default, there is an example gRPC API available with Backstage. And as you can see, it shows a raw example of a simple hello world type of a simple hello world example. There's also docs. You can create your own documentation, and also version control. It's all marked down. And finally, you can create. So there will be available templates for you. You can also register existing templates. So if a template already exists, open source somewhere on the web, and it has a catalog info file, you can just point to that URL and Backstage will pull it in. I haven't looked too much into this, but I think it can give a much larger analysis of what kind of things, and by things you're doing within the organization, by things I mean like, what kind of languages are being used, what kind of tools, what kind of practices are being done, what kind of CI/CD. So this is a pretty neat chart that's available off the shelf. So we're going to start by now pulling in our GitHub repository. So let's look back. The first thing we need to do is configure the provider, which we just did. We also need to define it inside of catalog. So inside your app config.yaml, you're going to go underneath catalog, and you're going to add a provider for GitHub. So this is going to be on the same level as location, providers, GitHub or GitLab, custom provider ID. You can put anything in here. It's basically just a name referring to your custom provider that you're adding. Host is obviously github.com. And that's it. You can have multiple providers as well. I can add a definition for GitLab here as well. And I can pull in both GitHub and GitLab resources. So found 3 new secrets in config. So I'm just going to refresh the page. Oh, I need to add after configuring your provider, you do need to tell the code to pull those packages in. So we're going to go into catalog entity page. Is it on the back end? Yes. So packages, backend, source, catalog. You're going to need to pull those in. So we will create backstage.io/docs/integration/github/discovery. If you do a search for GitHub discovery, this page is going to provide you the details of what you need. So you do need to install this plugin that's available for fetching fetching GitHub repositories for your catalog. So I'm just quickly going to kill this. Run this yarn command to install that package. While it's doing that, you do need to import the entity provider. So once that's available, the squigglies will go away. And just going to add this builder, GitHub entity provider builder. All right, and as we can see, the frequency where it would automatically refresh is currently at 30 minutes. There is a blurb here about API rate limits. Since it's using the GitHub API, you do want to be cautious of that. But we definitely won't be exhausting that for this workshop. So I'm going to rerun the application. Catalog.providers.github.provider.organization. Okay. Looks like I'm missing a configuration for organization. So we need to obviously point to where these repositories are coming from in rhythm workshops. So I'm going to just re-trigger the build and give it a minute to load. Add credentials. Oh, this token. My personal access token is supposed to go there. So make sure you do replace it with the valid value. Okay, added my token in there. Now let's see. Need to kill the server again. Apologies. And as I mentioned, the key aspect that we're seeing here is the discoverability aspect. As long as all these repositories have the catalog-info metadata available in the root of the project, Backstage can pull it all in and provide it as the service catalog. There we go. As you can see, we have Pulumi with Python that exists on the InRhythm workshop, and we have Terraform InfoCost as well. And I can click into these and get all the relative information for these. I can click on this, view the source code. It'll take me directly there. CI/CD. So this CI/CD part, it is configured. And we did have it. Actually, okay. It might be a remnant of when I previously tried this. Terraform InfoCost, the CI/CD, does use a plugin, a Backstage plugin that's needed for rendering out GitHub Actions. And as you can see, this is my CI/CD pipeline that's available on the Terraform InfoCost page. Terraform InfoCost, if you go to Actions, you can see these are all the runs that we've executed, and I can replay it from there as well. I can replay it from this portal. I'm going to rerun the workflow. There is going to be a lag since it needs to fire off the appropriate API calls to make that request. And as you can see, this build is now running. So it's kind of has everything centralized in such a way that you really don't need to leave this developer portal. Everything with regards to your repository can be maintained here. There are tabs for API. If there's any API that this project application consumes, that's available within the Backstage catalog. They will be referenced here. Any dependencies, if there's any dependencies with other components, I can define the dependencies within the catalog info YAML file. All of those would be here. And documentation. If you want to add documentation, you can set this annotation and provide markdown docs that would be rendered here specific to your project. So the capabilities are definitely pretty endless here. So along with Terraform with InfraCost, we also got Pulumi with Python. Well, all with similar capabilities. Yeah, so this pretty much shows how discoverable it is to find all the repositories within Backstage for your internal organization. Everything shows up here.
That's
All right.
awesome.
Yep. So now, next, we're gonna take a quick look at the templates. Because what we get from Backstage is not just the discoverability aspect of it, but the templating as well. The ability to standardize best practices for our products. So here in the examples directory, you're going to see an organization definition and an entities definition. These you don't need to touch. It's basically all the entities that you can kind of define for your resources. They use the keyword kind, and you can specify whether it's a component, it's a system, it's an API, it's a user. So all of that is defined here. Template is what we want to look at. So the template directory, template.yaml, provides the definition for scaffolding this template. And here we have an example Node.js template. So what this is going to do, it's going to create a Node.js project within the configured source code control management provider that we configured earlier. And basically, it's going to fetch that template from this content directory. So here, as you can see, we have a catalog info.yaml. We've got an index.js and a package.json. And there's values in these that could be interpolated. So anything we can render out a form for them to fill out, and the values provided in the form could that then be interpolated into the project itself. So let's take a look at that. So here's my example Node.js template. I'm gonna press choose. It says fill in some steps. What is the name of the project? Sample Node.js app. Next step, choose your location. I've only configured github.com, so it's there. The owner is InRhythm Workshops. That's the organization. And the repository, the name of the repository will be sample Node.js app. Step one, I believe, was the name of the project. This is going to be the name of the repository. Next step, it's going to review, show you all the repo URL and the name of the project. So we're going to click create. And there it is. My boilerplate has been provisioned. It's available within InRhythm Workshops. Straight from here, I can see it in catalog on the homepage, or I can see the repository URL. There it is. It comes with the catalog info.yaml. The placeholders were interpolated, as we saw, and as you can see, it's within here. Sample Node.js app. It's been created for you straight from Backstage. This is a sample boilerplate, but we could definitely do something similar for something much larger, much larger. So let's do a quick example where we can provision the repository and then upload it to S3. So I'm going to, let's first need to create a boilerplate. So let's, I'll use create React app. It's pretty straightforward. you're going to place whatever boilerplate it is that you want to templatize. You can, I don't know if that's a word, templatize, but you can put that under template. And here I just created a new directory, CRA boilerplate, create React app boilerplate. This is a directory I cloned from GitHub. Yeah, you can simply clone this, copy it into your directory. And I need a template definition for this as well. So I'm going to create a new CRA.yaml. And I'm going to pretty much copy paste everything here. So just update the name and title values so it renders differently. The steps are going to be the same, and I'm going to use a new scaffolding action. So this is an input. Underneath the parameters, you have several inputs that you can provide. I have one for choose the location, add the name, and upload to S3. And all you need to provide is the S3 bucket name. So we have that. And inside of steps, you're going to add this upload to S3. So this needs to be installed. It's another package. You can do a search on npm.js for a scaffolder backend module AWS. So you want to install this. Simply just follow the commands there. And while that's installing, provide you the instructions within the plugins directory. Inside of backend, you're gonna add to the scaffolder. Scaffolder. I'm gonna import the new plugin I just added. I just need the AWS S3 action. And I'm just going to add that action. Oh, I don't have an actions here. That's why I'll create it. Const actions. Actions. Just right. I don't need that. Integrations. Oh, I do need to define integration. Comes with default. I'm just gonna import that here. SCM integrations from Backstage integration. Do need to all it takes is a config. Config, that's going to be that config. And a reader is also from the input. Got to import that. And following this, logger, config, database, catalog client, logger, config, database, catalog client. Okay. So we've added that to our scaffolder. This is going to help us the key here is this create AWS S3 action. Now within our configuration, we can define an action to basically upload to S3. These actions are, as you can see, coming from the scaffolder plugin. So ultimately, we can write our own to do whatever it is that we need to do for our boilerplate. So the action defined as per the docs is authentication. This is optional. Okay, it's optional. I've already have my AWS profile set in context, so we should be good to go here. As you can see, the action is this, and the input it takes is the region and the bucket. So I provided that here. Path is build. There is a bug with this. We'll see it when it renders out. And at the bottom, I've added, we saw that when we provisioned the repository, there was a repository link and an open in catalog link. I've added a project site link, and the URL, the bucket name that the user provides, along with the common S3 default domain. Run this. All right, let's this load up. As you saw, we created that sample Node.js app. Backstage was able to pull it in. So anytime you create new applications through Backstage, it can automatically identify that a new service or a new project was created. Okay, so I'm going to click create. All right, there's probably what else? Right, I'm missing something. We did create plugin folder. All the actions. It's just hanging there. Let me see. Actions. Didn't add it to here. Right. Missing something else. My integrations, discovery, integrations, config, line reader. That matters, but it should be fine. I'm gonna try killing the app. Usually helps. Restarting.
You'll turn it off, turn it back on.
Almost there. Let's see what else. Okay. All right, that's fine. I'm just going to check out from our branch. Right. Restart one more time. Let me go reinstall my packages. Sorry, just 1 second.
This is good. It's good knowledge to have. I mean, like, you know, some of these troubleshooting instances like this. I mean, this is the stuff that people don't really see behind the scenes. Like, how you get from A to B, you know, it can be easy or hard, but you know, getting into these debugging scenarios.
Yeah, and of course, you know, when we're doing it on our own, everything works perfectly fine.
Oh, of course.
It's only during demos
Yeah.
and workshops when it decides not to work. I checked out to my step 3 branch on the InRhythm workshop on the Backstage demo repository that we have. So hopefully we should be good to go. Oops. Is anybody following along or trying it for themselves?
So I got Backstage to launch,
Okay.
but I must have done something wrong at one of the points because it launched, but it wasn't able to pull in. Could not fetch catalog entities. So I got Backstage launched and everything. It's just having trouble finding the entities. So I'm probably just gonna go back and rewatch this video and figure out where I did wrong.
All right, this is the expected result. We're supposed to see this example CRA template that I can pretty much choose. Once again, sample CRA app. Next step. InRhythm workshops. Sample CRA app. So this is missing the one second. I just need to get the configurations. We did update. We did add in the scaffolder plugin for AWS S3 last. All I need to do is just input a new input field to accept the S3 bucket, and we should be good to go. Let me just pull that up. Adding the title upload to S3 required. That is a property. Yeah. That is a bug on their library, on the documentation at least. The property belongs on the outside. So this is going to accept the S3 bucket, and now I'm just going to add a step for it, and we should be done. S3 URL, and the URL is going to be and just going to substitute the name for this. So the app restarted. Why did I? All right. So what we're basically trying to do here is that not only is it going to create the repository, but it's also going to take me, it's going to deploy it straight into the S3 bucket that I provide as an input. All mapping items must start at the command line 77. Oh, steps is repeated. See, S3 upload to S3, that input is now there. Sample ceiling app, GitHub, shots. And the name of the bucket is going to be this. Voila. There we go. So we were able to take it all the way from, creating the template. This was also provisioned in the sample CRA app was also created. This is a full-blown sample application. It's got everything in it. It's also got the catalog info.yaml defined. So we should be able to discover it as well, since I've just created it. So let's go to home, and there it is, sample CRA app, with everything related to it available as well. It should be the CRA application. So, oh yes. Oh, no, it didn't. Let me double check that. It seems like it did fail. Let's create another one. But ultimately, so the MIME type that gets sent when the files get uploaded are of octet string, and that's not what S3 expects.
I think you used CRA app 2 for choose location.
Yeah, I'm creating a brand new
Oh, okay, sorry.
yeah, this form is going to create a brand new repo. So I'm gonna attempt to try that again. We can portion this out, like we had the template for creating the CRA app. I can have a different card, a different item that says upload repository to S3. So that way it's broken out. The steps are broken out. Right now I have it chained into one card, example CRA template, which is why, I'm following the steps of that template, which is going to create a repository for me, then upload to S3.
Gotcha. My bad.
But that would be a better design, as you mentioned, to have it separated. So I'm going to create that. I'm gonna restart it one more time. But basically what we're supposed to see is the CRA sample application. And oops. And it's very fast. It runs in a couple of seconds. So you don't have to wait for a very long time. Oh, it's because I mentioned the code path. So if you notice the issue, it's actually attempting to upload all of this, which is not what we want. We actually want the build output files, the static assets that get generated after this project is built. This is the raw application data being uploaded. So what I'm going to do is go into example CRA template CRA boilerplate, and just going to run this, I believe. Check the package.json build. Yeah, build. Oh, I need to install the project, obviously. So this is going to install React scripts and all the build tools required for that project. Once again, a better approach would be to automate this via CLI. So it could be done straight from Backstage rather than doing it here. Okay. So the problem we're going to ultimately run is that this build directory, it's a plugin with a scaffolder, the AWS scaffolder. What it does is that when it puts the objects into S3, it adds the content type of octet string. So index.html, that's a text HTML MIME type, but it inputs it as an octet stream. And octet streams, if you open octet streams in the browser, I think it's going to attempt to download it, which is not what we want. We just want to render it. So I'm just going to show that. And this is a known issue. Right here. The AWS SDK sets everything to application octet stream. This issue is still open. And this is the problem I'm facing. Not only this, there are several plugins with many issues on Backstage. So, open source contributions are highly recommended. It'll help further better these plugins, but also, people are ultimately creating their own since it's highly configurable. So that also helps as well.
It's like this is really cool, man.
Yeah. Yeah, once we upload it, the main idea is to show that you can have a full end-to-end flow, creating the template with all the necessary tools you need and having deployment as part of it as well. And that point you brought up earlier, James, ideally I would separate the upload to S3 as a different available service and connect those two together. So provision the application and then upload to S3.
Nice.
Should be skipping those. No, usually that's not supposed to be. Delete it for now, and just to move this along. because that's there. Here we go. It uploaded everything. So if we take a look at index.html, setting it as a octet string. That shouldn't be happening. So if I do try to access the URL, properties, that's what we had in the Terraform example. It attempted to download. That's because the other files are also octet strings, I believe. Let me take a look at that. Yeah.
Interesting. So you're saying there's a bug with AWS that if it's an octet string, then it tries to download it instead of rendering it?
Yeah, it shouldn't be of type octet string. It should be, you know, whatever their respective MIME type is for that file extension.
Interesting.
So yeah, that is an open bug, as I shared here. So for the purpose of this, I'm just going to delete these. Um, yeah, it should be the respective MIME type or whatever, you know, those file extensions are. But it wasn't following that. So let's see. Oh my God, it wasn't opening because thing my meeting controls were in the way. Okay, just gonna upload the folder left for this. There we go. So the React boilerplate, as we can see, it's rendering out. Obviously there was that issue that I mentioned, but you know, it's a wonderful platform. It does provide a ton of capabilities. And you know, it's all useful. It's definitely useful in terms of shifting the culture and process for an organization, allowing for standardization, allowing for discoverability in a way that, you know, that organizations and large enterprises have been struggling with in the past. So definitely highly recommend, you know, you guys start adopting Backstage for your internal organizations, and you'll definitely see in a shift in culture and reusability, standardization, and just having a better experience, and fostering an inner source culture as well within your organization.